yesterday we went over some more of completing the square, looking at vertices. We also looked at our horizontal parabolas as well as reviewed the vertical parabolas. Now we're going to move into a more formal definition of what a parabola is, okay? The full geometric definition. A parabola is defined by any line where every single point on that curve is the same distance from a specified point called the focus and a line perpendicular to the axis of symmetry called a directrix. So I can pick any point on that curve and the distance of this line or the length of this line is equivalent or congruent to the length of that other line. Okay, every single point on that curve. And that's our formal definition of a parabola. If it meets that criteria, then it is classified as a parabola. So every single point will be equidistant from here as it is from the directrix. Okay? So there's some interesting features that we have with the focus and the directrix with the parabola. First and foremost is that the vertex, okay, which is a point, has to be the same distance from the focus to the directrix. That means that the vertex is going to be right smack in the middle between the two. The vertex is going to be that midpoint between the directrix and the focus. Okay? So we know that those two lengths are going to be the same. We call this the focal length. Okay? We call that the focal length. All right? And when we look at our formula, the focal length is actually the value of P in the formula that we're going to see later today, as well as the one that I showed you yesterday. So that focal length is that value of P. Okay? That focal length. We also have another part. We have the this line that is parallel to our directrix here and here. Okay, that line that's parallel to our directrix but runs through the focus, we call that the focal width. Focal width. Okay? That focal width is 4 times P. Okay? That focal width is going to be 4 times P, and you'll see in the equations 4P, and you wonder why is it 4 times P? Well, that's because that's represents that focal width, 4 times P, and then P being the focal length. We do have a formal name for this. In Latin, it is the latus rectum. So if you ever see that, it's asking for that focal width. Okay, that line is called the latus. All right. The other fun thing is if we take the focal width and we cut it in half, let's take another color here. Let's do purple. Okay, so the distance from the focus to the parabola along the latus rectum is going to be the same length as the distance from the focus to perpendicular down to the directrix. Those are also going to be the same distance. Okay, so we have a lot of relationships between the focus and the lengths of those lines in using that information for different things. Okay, so these are our more formal definitions of the parabola, and so we consider these vertex form. It's a little different than the vertex form we saw yesterday, just because we use a different coefficient. Yesterday, and in the past, we've been working with a vertex form that looks as such, plus k. All right. Notice the difference is just the coefficient. All right, we've been using A as the coefficient, but if we're looking at this geometric definition, we use a different coefficient, 1 over 4p, because we're using the relationship of the focal width and the focal length to write our equation or to graph our function, whatever it is. So we just kind of change the way that we write the coefficient, but you'll notice that everything else is exactly the same. Okay, so vertex form, we're just changing out A for 1 over 4p. That's it. Okay? Same thing though. It's still vertex form, still identifies our vertex. So when we're trying to write equations, we have to make sure we can identify what type of parabola we have. Is it going to be a horizontal one or is it going to be a vertical one? And so we have to look closely at the features that are given And I usually recommend drawing a little sketch so that you can visually see that relationship and visually determine what direction your parabola is going to open. Okay? So they're going to give you two pieces of information. They're either going to give you the focus, the vertex, and or the directrix. Okay? Usually two of those three pieces of information is all you need in order to fill in everything else. Okay? So here they give us the focus and the directrix. All right, so let's draw a little sketch to visualize this. All right, so I just have a little coordinate grid there. Doesn't have to be perfect. So the point 0,5 is located on what axis? Where is the point 0,5 located? The y-axis. Up here, right? Okay, so there's our focus. Our directrix is a horizontal line. We know it's a horizontal line because it's y equals 1. All y equals equations are going to be horizontal lines. So we have y equals 1. Is that going to be above or below the point that they gave us? It's going to be below, right? So here's our directrix, and here's our focus. All right? So the directrix is going to be below the vertex, or the opposite side of the vertex as the focus. Our parabola always opens in the direction of the focus. Okay? So our vertex is going to be halfway between the focus and the directrix, and it's going to open in the direction of the focus. It's going to open in that direction. Okay? So I know my parabola opens up. That means it's a vertical parabola, which means I need to use the proper formula for the vertical parabola, where x is squared. X is squared is our vertical parabola. Y is squared is our horizontal one. So we know we're going to be using this formula for our equation. And so to fill this in, all we have to have is the value of P, the value of H, the value of K. Well, where do the values of H and K come from? What is H? The vertex. So we need to find the vertex. Okay? And then P is that focal length, that distance from the vertex to the focus. So we have to know where the vertex is, and we have to know where the focus is in order to find P. All right? Those are the only things that we need. So looking at the fact that we know where the directrix is and we know where the focus is, let's kind of think about it. I'm going to draw a bigger diagram so we can kind of look and see. Okay, so at y equals 1, we've got our directrix, and then, what is it, 0,5? 0,5 is our focus. And we know our vertex is going to be right smack in the middle, right here. Okay? Well, what point is directly in the middle between the focus and the directrix? 0. Okay? So this point, we want to find something that's in the middle. What we can do is we can draw another point on our directrix that's all in line with the other 2 points and say, okay, well, if y equals 1 and x equals 0, we know that this is the point 0, 1. And we want to find the midpoint. Sometimes you can just, through inspection, look and figure out what that middle value is going to be. It might be a little bit more complicated. And so what we can always use is our midpoint formula. Our midpoint formula is the sum of the x's divided by 2 and the sum of the y's divided by 2. That's our midpoint formula. So if I need to find the middle, we can use our midpoint, given the focus and a point on the directrix that is in line with the other 2 points. And so I can put in my x values, I can put in my y values, and when we simplify, we get the ordered pair that is our midpoint being our vertex. Our vertex is that midpoint. And so we're able to find our vertex as 0, 3. All right, and then we need to find the distance between the vertex and the focus. That's what our value of P is. That focal length is the distance between the vertex and the focus. Well, how do I find the distance between 2 numbers? That's how you find the middle between two numbers. How do I find the distance between the two? Same as finding the difference. Distance between two numbers, if we're just going parallel or perpendicularly to the point, we're just going to subtract. If my vertex is at 0, 3, if I subtract 5 and 3, that gives me the distance, 2. Okay, so I have my p-value, I have my vertex. That's all I need to write my equation. Okay, now there's two ways that we can write it. Vertex form will be the first one. We'll start with that. All right, so we'll start with our vertex form. We know it's a vertical parabola. We're going to use the proper formula. All right, so leave y alone. What's our value for p? 2. What's our value for h? It's the x value of our vertex. What's the value of k? The y value of our vertex. Focal length, x value of the vertex, y value of the vertex. Just got to fill those in, and then we're going to simplify that expression. 1 over 4 times 2 equals what? Okay. X minus 0. Well, minus 0 doesn't change anything, so do I need that minus 0? So it just becomes x squared plus 3. So that's our vertex form. The other way we could write it is in standard form. I showed you guys this equation yesterday. We're going to write it again. Our standard form, x minus h squared equals 4py minus k. Okay? We can rewrite this equation in a couple steps to get to this one. Alright, if you don't need to, I'll give it to you. Just need to make sure you know the difference between vertex and standard, because they're going to ask us. Sometimes they'll say, give the answer in standard form. Give the answer in vertex form. You need to make sure it's in the correct notation. If it doesn't specify, either one will work. Okay? So, we've got our standard form. We're going to plug in h, k, and p again. X, what's my h value? 0. Okay? Minus 0, is that going to change? No. I don't really need to write it. I can just go straight to x squared. Okay? What's my p value? 2. So, 2 times 4 gives me what? 8. And then what's my k value? 3. Okay? Very similar equation, all the same information, just presented in a different way. So instead of 1 over 8, we have 8. Okay? Because what we did, we actually multiply the other side. Alright? Instead of plus 3, we have minus 3. We can rewrite this equation in standard form by subtracting 3 and then multiplying by 8, and we get 8y minus 3 equals x squared. Same equation. Okay, so we can go back and forth between them pretty easily. Alright? So, same equation, just a different notation. Alright? Notice in the different forms, with vertex form, there's a sign switch on h, but in standard form, there's a sign switch on h and k. Okay, there's a sign switch on both of those. So you got to be really careful when you're looking at those formulas. Pay close attention to the details. All right? But either one of those is sufficient. Vertex form. Vertex form or standard form. Okay?
So the signs of h and k are always negative, like if the equation had a negative sign.
That negative in the formula says switch the sign. Okay, that's what it says. All right? So we do it again. We've got the focus and the directrix. So my focus is located at 0, -3. What axis is that on? 0, -3. Where is that located? Y-axis, above or below the origin? Below. Okay, so we've got 0, -3, and that's my focus. All right. Directrix y equals 3. Is that going to be a vertical line or a horizontal line? Horizontal. Y equals 3. Is that above or below my focus? Above. Okay. It's going to be up here. All right. So there's the directrix at y equals 3. All right. So if we want to pick a point that's in line with our focus, our vertex is going to be somewhere in the middle. What is this point right here going to be? What's that red point going to be? It's on the y-axis and on the directrix. Now I want to know what ordered pair is this point right here. If it's on the y-axis and it's also on the directrix, what is that ordered pair? 0, 3. We're going to use that in helping us identify our vertex. Our vertex has to be right in the middle. What's going to be right in the middle between 0, 3 and 0, -3? 0, 0. There's our vertex. Okay? So we know where our vertex is. We know where our focus and our directrix is. We need to know which way our parabola is going to open. What direction is it going to open? Down. Open in the direction of the focus. So we're going to go down. If our parabola is opening in the negative direction, our p-value is negative. Because we need that leading coefficient to be negative. So if we're opening in the negative direction, then p will be negative. P will be negative. It would help if I spelled that even closer correctly. There we go. I'll be okay. All right. So we got our vertex 0, 0. How do I find my p-value again? Okay, subtract what? Say again? Well, the -3. Because it's the distance from the focus to the vertex. So we're going to do the -3 minus 0. Well, what's -3 minus 0? -3. Our p-value is -3. We're going down 3 units to get to the focus. We've got all of the information we need. We got our vertex and we got our p-value. So we plug it in. Y equals 1 over 4 times -3 x minus 0 squared plus 0. What is this going to simplify? Yep. We don't even need the plus 0. Just x squared. 1/12 x squared. I'm going to skip the next one. Go to slide 15. It's more of the same, and I want to make sure we have plenty of time on important stuff. All right. Where's my focus located? Okay, where is that? On the left, on that x-axis, -2, 0. Okay, there's my focus. And directrix, x equals 2. What kind of line is that going to be? X equals 2. So now we've got a vertical line at x equals 2. So what direction is our parabola going to open? To the left, towards the focus. Towards the focus. Going to the left. So my focus is at -2, 0. What is this point that's in line with our focus, vertex, and directrix? 2, 0. So if my focus is at -2, 0, my directrix is at 2, 0, where's our vertex at? 0, 0. Okay, so we got another one on the origin. Don't worry, the next one we're going to move off the origin. So we've got our vertex at 0, 0. What's our p-value? We have 2. 2 units to the left to get to our focus. So we have a horizontal parabola, which means we need to switch to the horizontal parabola formula. We need to make sure we're using the one where y is being squared for a horizontal parabola. Okay? And make sure you follow it really carefully. X equals 1 over 4. What's my p-value? Negative 2. Y minus, what's my k value? 0. What's my h value? Also 0. So we get negative 1/8 squared. So when we're on the origin, we won't have much plus or minus because vertex is 0, 0. But on the next one, we're going to move off the origin. We're going to have a vertex somewhere else. So we have a vertex at 3, 4. What quadrant is that going to be located in? Located in quadrant 1, up in the top right. So 1, 2, 3, 1, 2, 3, 4. Okay, so there's my vertex at 3, 4. Now, our focus is at 5, 4. So relative to our vertex, where is that going to be? Left, right, up, or down? From our vertex, we're going to go over right just a little bit more to get the focus. Okay, so this is our vertex. What direction is our parabola going to open? To the right, towards the focus. So that means our directrix has to be somewhere on the left, right? Okay, so if my focus, how far away is my focus from my vertex? 2 units, so we have a p-value of 2, right? So if my vertex is at 3, 4, what's going to be the x value of the directrix? Focus and vertex will be equidistant compared to directrix. So if our p-value is 2, we're going to go 2 units in the opposite direction to get our directrix. All right. So we've got our vertex that was given. We've found our p-value comparing it to the focus. Now we have everything we need to write our equation. We did the first few in vertex form, so let's do standard form for these next ones. So I have a horizontal parabola. What needs to be squared, x or y? Y needs to be squared for a horizontal parabolas. Y minus k squared equals 4p x minus h. All right? Now think about this carefully. What's my k value? Two numbers. What's my k value?
1.
Not 1. It's 4. K is 4. So y value of the vertex. What's my p value? What's my h value? The x value of the vertex. And then we simplify it. Y minus 4 squared, can't really do anything else with that. 4 times 2 gives me 8. Then we have x minus 3. So there's our standard form. We'll plug in the same values if you want a vertex form, just into the vertex form equation. So again, you'll be given 2 or 3 pieces of information. You need to use those to find either the vertex and focal length. Those are the only 2 things that you need in order to write your equation. Now, if they don't give you those, they're giving you the equation in general form. we still need to know the vertex and the focal length in order to get the vertex, the focus, and the directrix. But we can only get those from either vertex form or standard form. Both of those require completing the square. Okay? You can do either one. It's up to you. We'll go through both. It's a slight change. They start out the same, completing the square, and then there's a slight variation in how we finish it. And then you just interpret the information a little bit differently to get your p-value, to get your vertex. So it's up to you which one you want to use. Just make sure you're showing your work. So what's being squared in that parabola? If y is squared, what direction is our parabola going to be? Horizontal. Is it going to open left or right? Positive, so it'll go to the right. Y squared is positive, so we're opening to the right. So we know our parabola is going to be something like this. Okay, we know that our focus should be to the right of our vertex. Our directrix will be a vertical line to the left of our directrix. So now we need to complete the square. We need to group the terms that we want to make a perfect square trinomial to one side and move everything else to the other. Y squared plus 2y. Let's have our box for completing the square. And then we'll add 6x and subtract 13 to move it to the other side. And again, let's not forget the box. How do I figure out what goes in that box again? 2 squared. What is b over 2 squared going to end up equaling? 1. Our left side will factor to be y plus 1 squared. And the right side will simplify to be y plus 1 squared, 6x minus 12. Okay? So that's that first part for completing the square. This is where it's going to differ depending on which form you want to use. Let's do vertex form first. Vertex form is just get x by itself. We want to isolate x. So what can I do to isolate x? So we'll add 12 to the other side. And then we will divide everything by 6. So we'll have 1/6 y plus 1 squared plus 2 equals x. So our vertex form is 1/6 y plus 1 squared plus 2. Okay? Compare that to our formula. We have 1 over 4p y minus k plus h. What's the x value of my vertex going to be? H is the x value, h is 2. 2 is the x value of our vertex. What's the y value of our vertex? -1. Okay? In order to find directrix and focus, we have to know our p-value. Compare these and think about how could we find our p-value. What could we do with the knowledge that our leading coefficient is 1/6 and in our formula it's 1 over 4 times p? Any ideas are welcome. You don't have to be afraid. No ideas on how to figure out what p is? Interesting conversation.
But you can't do that because
No solutions, no idea. That's true, but how do you figure that out? Yeah. 6 is 4p. So how do we write that out mathematically? Back up a step. If 6 has to be 4p, how do we? 6 equals 4p. Divided by 4. That's how you get p. Yeah, but just jump straight to the answer without any stuff in between. There's 20 other people in this room. If I have the fraction 1 over 6 equals, and it has to be the same as 1 over 4p, well then logically 6 has to equal 4p. So we set 6 equal to 4p, solve. We divide by 4, we get 3 over 2, or 1.5 for your value p, for your focal length. Your focal length is 1.5. So now let's find our focus. Using that 1.5. Where is our focus relative to the vertex? Is it left? Is it right? Is it up? Is it down? To the right. When we move to the right, what value are we changing? X or Y? Changing our X. So we're going to take that focal length and use it to change the X value of the vertex. Are we going to add it to our vertex, or are we going to subtract it from our vertex? We're going to add it. We're moving to the right, we're going to add it. Would I add it if I want to go to the left? Subtract it from the X value. So we're going to take the X value, add our focal length, leave the Y value alone. So our focus is located at 3.5, -1. What type of line is our directrix? What type of line is our directrix going to be? Now we drew a sketch up at the top. What type of line is our directrix? Vertical, which is x equals. So our directrix is going to be x equals, and then again, are we going left or right from our vertex? Left. So it'll be the x value or vertex minus our focal length. The x value of the vertex minus the focal length, because we're going in the opposite direction. We added our focal length to get our focus. We're going to subtract our focal length to get the directrix. If my parabola opened the opposite way, then we would do the opposite thing. If we're moving to the right, add. If we're moving to the left, subtract. If we're moving up, add. If we're moving down, subtract. So what's my directrix? 0.5. So we've got our vertex, we've got our focus, and we've got our directrix. 3 key features of our parabola. If you want to get the same information from standard form, well, let's go back and get standard form. Okay, so this is where we deviate for vertex form. And then over here, we're going to go ahead and do standard. So let's compare it to our formula. Let's see what we need to do. Our formula is y minus k squared equals 4px minus h. Left side, does it look like that? Does the left side already kind of look like that? Yeah. Okay, so our left side is probably good, right? Compare the right side to the right side. What's different? What are we missing? kind of. In a sense, we're missing P and H. But structurally, what's different between what we already have in blue and what we need to end up with in teal? Say that again. Okay. So here we just have x by itself, and here we have a coefficient. Someone said something. Now factor it out. This is distributed. This one is factored. So let's factor it out. If I factor out 6 from both of these, what am I left with? What am I left with? Quantity x. So now we're in standard form. A little faster to get to standard form. But we got to be really careful when we're filling in the values of h and k and p, right? Now, just like we did here, well, 6 has to equal 4p. 6 has to equal 4p. So we'll still get the same value for the focal length. Here we have negative k equals 1, so k equals negative 1. And then here we have negative h equals negative 2, so h equals 2. So we still get the same values for h and k and p. It's just presented in a slightly different way. So you can use whichever one you want to fill in and find the vertex, the focus, and directrix. I recommend vertex first because that's going to be the easiest to identify. And then use your vertex with the focal length to get the focus, and the vertex with the opposite of the focal length to get your directrix. Either one of those forms is fine. All right, we're going to skip to the last one for today. Here we go. How much time do we have? We have 2 minutes or 7 minutes? 2. We have 2? All right. Oh, come on. Okay. X is squared, so we have a vertical parabola. We have this leading coefficient, though, so we need to factor that out first in order to complete our square. But since we factored out a 3, we also need to multiply by 3 on the right. Okay? We'll go through and finish completing the square. Nothing different with this process. 3x squared, x minus 1 squared equals 6y minus 7. Okay? I'm going to put it in standard form just because it's a little bit easier. Either form is fine. You can either get y by itself or put it in standard form. I'm going to do standard form. We're going to factor out the 6. Since 7 can't be divided by 6, we leave it as a fraction. Divide by that leading coefficient. We get 2y minus 7 6. Okay? So our value for h is 1. Our value for p will be whatever that equals, which is 1/2. And our value for k is 7 6. Plug those into our formula, or use those to find your vertex and your focus and your directrix.